Thank goodness. Okay, so 20.2C notes. Now, yesterday, we talked about one way of distributing our data. So let me kind of go through this a little bit. We started off in Mod 20 with talking about population parameter sample statistics, yeah? Okay, so we went through what kinds of information you might want to find doing a survey or a census, etc. And then we went into the different methods of sampling. How could you get that data? Once you find out what it is you want to know, how do you get it? How can you get it where it's unbiased? After that, we started talking about what do you do with that data? You find the mean, the median, mode, the range. And how can you display that data, which was the box and whisker plots that we talked about yesterday. And today is more ways of displaying that data. So we've kind of walked through an entire process of starting with what do you want to know, all the way through how are you going to display your findings. All right? So we are going to make a line plot, also known as a dot plot, as well as a histogram. And then we're also going to talk about this thing of skewed versus symmetric. What does the word skew mean? You know? Tilted, off, lopsided, okay? Versus symmetric data, which is symmetrical. It's even on both sides, right? So, here is a table of data, okay? And this table of data actually is a very long table of data, but we wanted to save some space, so we cut off the bottom half and just placed it right up here. All right? What is this table of data talking about? What kind of information are they giving me? Okay, has to do with babies being born, right? So let's see. Baby number 1 was born in month 5, which is what? May. They were born in May. They weighed 3.3 kilograms, and their mother was 28 years old. So we have some information about babies and their mothers. Do you get that? All the way through baby 10, and then we continue on baby 11, baby 12. So we're looking at how many babies? 20 babies. So this is raw data. It has not been calculated into anything. That's what makes it raw. Okay, we haven't calculated any means, any medians, nothing like that. About 20 babies born in a hospital. Okay. A distribution shows raw data organized using the frequency that they appear. We're going to use frequency. What does frequency mean? How often something happens. Okay. Data displays for numerical data use a number line as a base and include box and whisker plots, line plots, and dot plots, and histograms. So all of those kinds of information use a number line on the bottom to give us some kind of reference. Histograms are very similar to bar graphs. They're just slightly different. A bar graph could have 300 bars, for all we care. It could have 1,000,000 bars on it. But a histogram usually only has 4 to 5 bars on it. It usually has larger groups, and I'll talk about that in a minute when we get there. Displays for categorical data do not require a number line because remember, categorical data doesn't necessarily have an order to it. You can use bar graphs for categorical data. You can use circle graphs or pie charts for categorical data. So you would represent your information in a slightly different way. Okay? What's the difference between a bar graph and a histogram? No number line on the bottom. Right? Bar graphs are for categorical. Okay? All right. So, we have some things called skewing. If this is my number line right here, okay, and I have graph where all of the information seems to be over here, and there's just low bars or low dots over here, we call that a tail. This is what we would say is skewed to the left. There is a tail that goes on the left. That means it's skewed to the left. It is also known as a negative skew, and we'll see examples of these in a little bit. When you have something like this that just goes up, that looks kind of like something we know as the bell curve. Have you heard of that before? The bell curve. In stats, it's known as the normal curve. So when you hear me say normal, I'm not talking about somebody who's strange versus somebody who's normal. I'm talking about the normal curve, which is this symmetric bell shape. We would say that is symmetric. Then we have skewed right, where most of our data ends up over here on the left, and we have this tail that's going off to the right. That would be skewed right, or skewed positively. Uniform is when they're all about the same, all the way across. Okay? Everything's about the same. And then we've got funky. We're not going to talk about that too much. Okay? So what we're going to do is we're going to take information from this table up here, and we're going to make a line plot, also known as a dot plot. Okay? So what is this category right here? It says birth month. So what I want to do is I want to take the 20 babies' birth months, and I want to put it on my little table now, or my chart down here. So baby 1, the birth month is 5. So that means I'm going to come down here, and where birth month 5 is, I'm going to put a little X there. What is baby number 2's birth month? 7. So I'm going to put a little X there. Baby 3's birth month? 11. Baby 4? 2. Baby 5? 10. Baby 6? 3. Baby 7? 1. Baby 8? 4. Baby 9? 7. And when I get to a second one, I just put it on top. Like I'm stacking the X's. What am I on? Baby 10 is 6. So I should have 6 X's. I should have 10 at this point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let me do the rest of them. We have birth month 9, 10, and 11. 9, 10, and 11. And then 1, 6, and 5. 1, 6, 5. 8, 9, 12, 2. 8, 9, 12, 2. So that's what a line plot looks like, or a dot plot. The reason why it's sometimes called a dot plot is sometimes they won't use X's. They'll literally put little dots and just start stacking the dots into little towers there. I have seen a lot of dot plots come up on standardized testing, SATs, the SBAC that you're going to be taking soon. For some reason, these types of plots come up a lot. Now, what do you notice about each of the little towers, or each of the little columns, if you will? Are there any that seem to be standing up particularly high compared to the others? No, they all seem to have 1 or 2 X's on it, don't they? So what would you say? Would you say that that could be skewed left? Would that be symmetric? Would it be skewed right? Or would it be uniform? I'd say that's pretty close to being uniform. Okay, so I would say that this one is uniform because they're pretty much evenly spread all across. All right, now let's make one for birth weight. That's information in my chart, right? Now, how do we have this broken up? 3.0, 3.1, 3.2, 3.3. So it looks like it's going, every line is a 0.1. Yeah? Again, this is something that has to have this number line to start off with. So I'm going to look at birth weight. The first baby's birth weight is 3.3. So I'm going to put that right there. Baby number 2 is 3.6. Then we have 3.5, 3.4. Do you see what I'm doing? 3.7, 3.4, 3.5, 3.2, 3.6, 3.4, 3.6 again, 3.5, 3.4, 3.7, 3.5, 3.8, 3.5, 3.6, 3.3, and 3.5 again. I'm even running off my chart, running out of the room I've got there. What do you notice about this one? It's not evenly distributed, is it? there is definitely a peak in the middle, isn't there? Does this peak seem to be over here on this side, making a tail on the left or making it a skew left? Does it seem to be right in the middle with tails on both sides that seem even? Or does it seem like it's skewed to the right? I would say this is symmetric. If I were to draw in the curve, it looks like it would be that bell shape there. Okay? Kind of sort of makes sense? And when you're talking about babies' weights, babies tend to be born around the same weight. You have a few that are a little bit lighter, a few that are a little bit heavier, but there is generally an average that's right in the middle. All right, now let's talk about mother's age. How am I going to do that one? Well, go through my list. 28. Let me do this. I'm going to do this one in dots just so you can see what the dots look like. They would just do this. 28, 31, 33, 35, 39, 30, 29, 30, 31, 32. And on the next column, 33, 29, 31, 29, 34, 30, 32, 30, 29, and 28. So that's what it would look like if it was the dots instead of the X's. Same way of putting the data. What do you notice about this one? If you were to picture the outline of this data, it does have this guy that goes down there, so it kind of goes like that. Is that uniform, symmetric, or skewed? Skewed. What direction is it skewed? Skewed to the right, because that's where the tail is, or we would say it has a positive skew. Questions about that? Now, I believe on your test and your group test, which is Friday, you do have to create one of these. I give you some data and a number line. You have to label the number line appropriately, and you have to either use the X's or the dots, I don't care, and make a line plot or a dot plot. Okay? We good there? All right. Now let's go on to a histogram. So, a histogram also has to have a number line down here. Okay? Now, we're going to take this same data that we did a line plot of, and we're going to show what it would look like if we did a histogram instead. Now, the good news is, on your test, as of right now, you do not have to create a histogram, but you do have to read information off a histogram. Okay? But we're going to take a few minutes to create one right here. In fact, I probably should get some different colors just to make things easier. Let's use some school colors here. All right, so let's see. We want births by month. Do you notice that this side is already labeled as the frequency? So whether it happens 1 time, 2 times, 3 times, 4 times, or 5 times, that means we're going to be putting the months along this one. So I'm only going to label a few ones. I'm going to label number 1, number 4, number 7, 10, and this would technically be 13, which doesn't really make a whole lot of sense because, what? There's not 13 months in a year, right? But that's okay. So, for this part with 1, I'm going to say that this is birth months 1 through 3. So if I look up here, how many babies were born in months 1 through 3? 1, 2, 3, 4, 5 babies, correct? So I'm going to do a bin or a bar that goes all the way up to where my next one's going to start that represents that I have 5 babies born in months 1 through 3. Does that make sense? So, by the way, part of what makes this a histogram is I'm not doing 12 individual bars, right? I'm grouping a few months together in each one of these bars. So that way you don't have a whole, the more bars you have, the harder it is almost to see some of these trends of symmetric or skewed. All right, the next one, I'm going to do months 4 through 6. So I'm dividing it into every 3 months. So months 4 through 6, how many babies were born? 1, 2, 3, 4, 5. So again, I'm going to have a bar, goes all the way up to where my next one's going to start. That is 5 high, representing the 5 babies that were born in months 4 through 6. Does that make sense? As everybody's digging through their bags for different colors. So what's my next bin going to be, or my next bar? Months 7 through 9, because that's 7, 8, and 9. That's my next 3 months. How many babies are born in 7 through 9? 5. Do you see that? So again, all the way up to where the next one's going to start. And then finally, this is really months 10 through 12. And this is going to go all the way to the end to where month 13 would start, but there is no month 13. And how many babies are born in months 10 through 12? 5. Good thing, because I already topped it off at 5. Do you see how much easier it is to see that that's uniform there? Very uniform. In every quarter of the year, there were 5 babies born. So? Okay. Now let's do the births by weight. We're going to turn it into a histogram. Okay. So again, frequency goes up the left side, so that's still going to be, I'm going to count every line as 1, but I'm not going to label every line because that would just take forever. So I'm just going to label 2, 4, 6, 8, 10. You okay with that? I'm counting every line as 1, but if I labeled 1, 2, 3, 4, 5, it would just get too squishy. I wouldn't be able to read my numbers. So just trying to keep it clean. Now, my birth weights, I don't start at 0 because we don't have babies that are born that weigh nothing. They all weigh something. And the data set that I have, what is the lowest weight represented? 3.2 kilograms. So I'm going to call this one 3.2. This one would be 3.4. This one would be 3.6 and 3.8. Again, I'm labeling these lines right here. Now, because I skipped some values, because I don't count anything from 0 kilograms up to 3.2 kilograms, I have to do this little zigzag thing. Have you ever seen that before? Usually it's on a vertical. But what that means is that I'm cutting out all those numbers between 0 and my starting point because there's no data there. So there's no reason to look at the graph there. Okay? So 3.2. So 3.2 to 3.3. Right? Because my next one starts at 3.4. So this is 3.2 to 3.3. How many babies do I have? 3. So I'm going to draw a bin that goes up to 3. So far, so good? Next one would be 3.4 to 3.5 because the next one starts at 3.6. So I need all my 3.4s and my 3.5s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a lot, isn't it? So that's definitely a bigger bin. You okay with that? Next one would be 3.6 to 3.7. So how many fit in that 3.6 to 3.7 bin? 1, 2, 3, 4, 5, 6. And then finally the 3.8, this would technically be 3.8 to 3.9, but we don't have any in 3.9. We just have one in that area. So that's what that bin looks like. Still look fairly symmetric. Yeah, it kind of evens each other out. Okay. And then finally, let's do our births by mother's age. So again, my frequency on this side, I'm going to count by twos. 2, 4, 6, 8, 10. Well, technically I'm counting by ones. I'm only labeling every other one. And then mother's age. Where does my mother's age go from? Looks like 28 is the lowest and 39 is the highest. So I'm going to start at 28. And then let's see, if I need to get up to 39, let's count by threes. 28, 29, 30, 31, 34, 37, and 40. That'll get me from 28 to 39 like I need. Am I skipping some values? I'm skipping 0 through 28, aren't I? So I do need to do that little zigzag thing to show that I'm skipping. So what is my first bin going to be? It's going to be 28, 29, and 30, correct? Because 31 starts the next one. So this is 28 to 30. How many dots are in 28 to 30? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's where my tall bin is, right there. Okay, my next one is going to be 31 to how old? To 33. How many is that? 31, 32, 33. How many is that? 1, 2, 3, 4, 5, 6, 7. And then the next one would be what? 34 to 36. And it looks like I only have 2 in there. And then finally 37 to 39. I only have 1 dot in that range. So I can pretty clearly see the tail going off there that shows me that it's skewed to the right or skewed positively. So? Okay, let's turn the page over to here. So here's another example of what it looks like when it has a negative skew or a skew to the left. Symmetric, no skew, also known as normal. Or a positive skew or a skew to the right. And then if everything seems to be about the same height, we call it uniform. Okay? So, let's fill in some things. Here is an example of one that is skewed how? Skewed to the left because we have a long tail that is on the left side of the peak. It is pushed away from the left side. And what do you notice about the mean with regards to the peak of the data? The mean is to the left of the peak. Does that make sense? Okay, let's look at the next one. We have a right skew. It is mounted near the center, however, it has a long tail on the what side? Right side. It is pushed away from the right side. And the mean is what? To the right of the peak. And then we have our normal curve. It is symmetric. It has no skew. It is mounted at the center. The tails on the left and the right should match. They should be about even. The mean, the median, and the mode are all at the peak. A normal distribution, such as this one, is considered the most common example of a symmetric curve, but we actually need to know more about the data to determine if it actually is an exact normal curve. And Mod 21, we spend the entire module talking about the normal curve. Okay? So here's an example from a recent census. What can you tell me about the skew on it? It is skewed to the right for a couple reasons. The tail's on the right. The mean is to the right of the peak, right? It is pushed away from the right side. It's pushed towards the left. That makes it skewed to the right. It might also say that it is positively skewed. Okay? All right, your homework is out of the textbook, section 20.2C. I went ahead and posted section 20.2C on Google Classroom for you so you can look it up. Just note the page numbers won't match. I want you to do all parts of number 1, only parts A and B in number 2, only parts A and B in number 3, only part A in number 4, and then all parts of 6 and all parts of 7. Okay? All right, happy studying.